How are you? This is Ambrish Kumar speaking. Today we are going to discuss some problems which were previously asked in JEE Mains. The first question that I'm going to write is questions position of a particle is related to particle is it is related to time. Position of particle is related to time as given by it is given by the equation. It is given by the equation x equals to t to the power 4 plus twice t. This is the question. Position of a particle is related to time as given by the equation x equals to t to the power 4 plus 6t cube plus twice t. So we have to find acceleration at so this is the question. Position of a particle is related to time as given by the equation x equals to t to the power 4 plus 6t cube plus twice t. We have to find acceleration at equals to 5 seconds. So answer. Okay. So what is acceleration? A equals to dv upon dt equals to d upon dt of dx upon dt. The velocity is velocity is dx upon dt, that is velocity, and acceleration is dv upon dt or d upon dt of dx upon dt, or this is d2x upon dt square. So this is the formula that writes acceleration, that expresses acceleration in differential form. Okay, so you have read the question. I'm going to rub it. Acceleration equals to dv upon dt equals to d upon dt dx upon dt. Since v equals to dx upon dt, so what we have, acceleration equals to d2x upon dt square. Okay. First we take the first differential of x. We have dx upon dt equals to 4 t cube 18 t square plus 2, and this is velocity. This is velocity. So we get velocity as dx upon dt 4t cube. We're differentiating this thing with respect to time. Now we take the second derivative. A equals to t square. We take the second derivative equals to 12 t square plus 18t plus 0. 2 is a constant, so when we differentiate it with respect to time, it becomes 0. So this is our formula. Now we have to find acceleration at t equals to 5 seconds. We have to find acceleration at t equals to 5 seconds. So equals to 12 into 5 square plus 18 into 5. No, 18, no, it is 36 into 18, 4, 12 t square plus 18 to 36 t. 36 into 5, so 12, this is 300 plus 180. This is So what we get for acceleration at t equals to 5 seconds as 480 meter per second square. So it's straightforward calculations that we have done. Position is given, we take the first derivative, that is velocity, second derivative, that is acceleration, and then we substitute the value of t equals to 5 seconds, and we get acceleration equals to 480 meter per second square. Okay. Now we are going to second question. Okay. Second question that I'm going to write is, a body moving with constant acceleration. Question is, a body moving, a body is moving with constant acceleration. A body is moving with constant acceleration covers 102.5 meter, 2.5 in nth second, in nth covers 102.5 meter in nth second, and covers 115 meter in n plus 2th second. Okay, covers n 2. So we have to find acceleration. Find A or we have to find acceleration. The most important concept it is given is that we have acceleration is constant. What is moving, constant acceleration covers. So for such motion, we have to memorize the formula. Sn equals to u plus a by 2 to n minus 1. This is for nth second. Okay. Now we want to find find it for n plus 2th second, equals to u plus a by 2 multiplied by 2. Instead of n, we put n plus 2 minus 1. Okay, this is n plus 2. This is the distance covered in n plus 2th second, and this is distance covered in nth second. Okay, we write it as equation 1 and equation 2. Okay, so we subtract Sn from Sn plus 2. So S n plus 2th minus Sn equals to this two, where they cancel each other, plus to a by 2. We take common, 2 n plus 2 minus 1 minus 2n minus 1. Okay, subtracting this in 2, we are subtracting 1 from 2. Okay, so Sn2 plus this is 115 minus 102.5. okay, equals to a upon 2. This is 2n plus 4 minus 1 minus 2n plus 1. Okay, 2 and 2n, they cancel each other. 1 cancel each other. So what is left is 4 equals to a by 2 into 4. This is 2. So this is right hand side, we get twice a, and left hand side what it will be? It will be 12.5. 115. We subtract 115. From 115 we subtract 102.5. So what we get is 12.5 equals to twice a. Acceleration equals to 12.5 upon 2 equals to 6.25 meter per second square. So this is the question. A body is moving with constant acceleration, covers 102.5 meter in a second, and covers 115 meter in plus 2 a second. We have to find acceleration. So this is the formula. Sn equals to u plus a upon 2 twice n minus 1. So for n plus 2 a second, instead of n we put n plus 2. Okay, and then we subtract Sn plus 2th second from our distance, and we get this acceleration equals to 6.25 meter per second square. Okay. So the next question that we are going to discuss is a particle of mass m. Question is a particle of mass m dropped from height h is dropped from height h. Okay, above the ground, from height h above the ground. Okay, after collision, what happens after collision? What happens after collision? It rises to height. Collision, it rises to height h by 2. So we have to find percentage loss in kinetic energy. We have to find percentage loss in kinetic energy during collision. Energy is mainly question. During collision and speed of particle and speed of particle just before collision. Speed of particle just before. What is the speed of particle just before collision? Okay. So a particle of mass m dropped from height h above the ground. After collision, it rises to height h upon 2, and percentage loss in kinetic energy during collision and speed of particle just before collision. So this is the question. I'm going to rub it so that solve it. Okay. Okay, so we have made sketch of the problem. Sketch of the problem. This is height and this is height h upon 2. Particle is dropped from this point, 0, A, and B we can call it. We are making notations for our convenience of understanding. So particle is dropped from h equals to 0. So what is the equation? We have b square minus u square equals to twice g h. Acceleration due to gravity is acting. So we have, for acceleration we have taken equals to g. Okay. What is the initial velocity? Initial velocity u equals to 0. So what we get is b square equals to gh. This is for case 1. Okay. So when the ball falls from height h and collides the ground, the velocity is 2gh. Now, after collision, it rises to height h upon 2. So in case 2, final velocity final velocity equals to 0. Okay. So initial velocity we have to calculate. What is the velocity after collision? We have v square minus u square equals to 2g into h upon 2. This distance is h upon 2. And what is the final velocity? This is 0. Okay. So u square, the body is moving up, so acceleration is down, acceleration due to gravity is down. So we have to put a negative sign here. What we get is u square second case equals to 2g h upon 2 equals to gh. So the final initial velocity in the second case, equals to gh, and the final velocity in this case is 0. We have to find percentage loss in kinetic energy. Percentage loss in kinetic energy equals to kinetic energy final minus kinetic energy initial divided by kinetic energy initial. So this is percentage loss in kinetic energy. We have to find kinetic energy final minus kinetic energy initial divided by kinetic energy initial. Okay. Kinetic energy final equals to half m. Final we have only u square, final initial velocity, half m u square second case minus what is kinetic energy initial? Half m v square first case divided by half m v square first case. This half m v square. So what happened? Half m they cancel each other. Half m they cancel each other. So what we get here is u square initial velocity in the second case minus v square first case divided by v square first case. Okay. So this is percentage loss in kinetic energy. Square of initial velocity in the second case, square of final velocity in the first case, divided by square of final velocity in the first case. Okay. We make substitutions here. We make substitutions. So what is u square in the initial velocity in the second equals to gh. The percentage loss equals to, we say, u square gh minus, what is v square in the first case? V square in the first case equals to 2gh divided by v square, for v square in the first case equals to 2g equals to minus gh upon equals to minus 1 upon 2, which is equivalent to 50% with a negative sign. This is equal, percentage loss is minus half. If we convert it to percentage, so percentage loss equals to 50% with a negative sign. This is the loss in kinetic energy. The particle which is released from a height h, it drops and hits the ground and then rebounds with another, with loss of velocity, and this is the loss in kinetic energy is 50%. Second part of the question is we have to find the velocity just when it is released from, what is the velocity just when it hits the ground, the first case. So in the first case, what happens, this is the velocity equals to, when it hits the ground, velocity equals to 2gh equals to, velocity equals to 2gh, v square equals to 2gh. This is the velocity when the particle hits the ground. Let me write it clearly. I'm rubbing it. Okay. These things are self-evident, clear. Second part of the question is that what is the velocity? What is the velocity when it hits the ground? So v square equals to 2gh. So what is v? This is the velocity when the body hits the ground in the first case. So the answer is root under twice gh. Thank you.